Hey everyone, and welcome. Today we're tackling a topic that is absolutely essential for every future pharmacist. We're talking about chemical incompatibilities, a huge deal for patient safety, and something you're definitely going to see on your exams. So let's just jump right in with a big question. What happens when the very drugs you combine to help someone actually become enemies inside the bottle? I mean, what if that medicine becomes totally useless, or even worse, turns into something toxic? Yeah, that's the challenge we're unpacking today. Okay, so let's start with the big picture view. What does it actually mean when we say that two things are incompatible in the pharmacy world? You can think of it like this. Imagine you're trying to mix up a perfect prescription, but something goes wrong, and the final product is just off. Maybe it looks weird, maybe it won't work anymore, or maybe it's become unsafe. That right there is pharmaceutical incompatibility. It's an unintentional and often harmful result of mixing things that just shouldn't be mixed. Now, this whole issue breaks down into three main types. You've got physical, chemical, and therapeutic. They're all super important for sure, but today we're zooming in on the one that's a huge focus for your university exams and where some serious molecular drama happens, and that is chemical incompatibility. So what really makes an incompatibility chemical? What's happening on that tiny molecular level that we need to be so careful about? Let's dive in and define it. Okay, so this isn't just about two ingredients not blending nicely. This is a full-on chemical reaction. We're talking about molecules literally getting torn apart and put back together in a new, unwanted way. And this usually happens because of things like oxidation, hydrolysis, or those classic acid-base reactions you learned about. And the results of these reactions can be really, really bad. You could end up forming a toxic product that could actually harm the patient. Or you could create an inactive product, which means the patient isn't getting the medicine they need. Sometimes you'll see visible clues, like fizzing, a weird color change, or decomposition. But sometimes the most dangerous changes are completely invisible. But here's the good news. As a pharmacist, you are not powerless here. You actually have a toolkit with two main strategies to handle these situations. And understanding the difference between tolerated and adjusted incompatibilities, well, that's going to be your secret weapon. Now listen up, because this slide is pure gold for your exams. The distinction here is critical. With a tolerated incompatibility, you're basically playing defense. You know a reaction might happen, so you change how you mix things to minimize it, like using more diluted solutions. But with an adjusted incompatibility, you're playing offense. You prevent the reaction altogether by swapping out an ingredient. The key thing to remember, though, is that the substitute has to provide the exact same therapeutic benefit. That's not negotiable. All right, that's enough theory for now. Let's make this real. We're going to walk through a couple of classic examples that you'll almost certainly see both in the lab and on your final exams. First up, we have a true classic. What happens when you mix acidic alkaloidal salts with alkaline substances? A lot of drugs, especially alkaloids, are made into salts to make them more soluble in water. But that also makes them acidic, which sets the stage for a major chemical clash. Okay, so picture this. A prescription comes in and it calls for strychnine hydrochloride solution, that's our acidic salt, to be mixed with aromatic spirit of ammonia, which is alkaline. What do you think is going to happen here? The problem is that the acid and the alkaline ingredients react and they form pure, insoluble strychnine. This stuff then literally falls out of the solution as a precipitate, which makes the dosage completely unreliable and dangerous. So what's the fix? This is a perfect case for a tolerated solution. We don't change the ingredients. Instead, we change the process. We dissolve each ingredient in half the water first, and then we slowly mix those two dilute solutions. This simple trick minimizes that nasty precipitation. Pretty clever, right? All right, ready for something a little more, explosive? Let's talk about what can happen when you mix strong oxidizing agents with reducing agents. Yeah, you heard that right. This isn't just a bad mixture. It's a potential bomb. If you try to grind or heat an oxidizing agent like potassium chlorate with a reducing agent like tannic acid, you could literally cause an explosion. So the solution here is simple. You dispense them separately, always. If for some reason they absolutely must be mixed, you have to do it with extreme care. No pressure, no heat, no friction. You handle it like a bomb disposal expert. Okay, that was a lot to take in. So let's lock it all down with a quick recap of the most important points you need to remember for your final exams. Think of this slide as your final cheat sheet. First, chemical incompatibility is an actual chemical reaction that creates a new unwanted product. Second, you manage it in one of two ways. You can tolerate it by changing your method, or you can adjust it by substituting an ingredient. And finally, always be on the lookout for those classic troublemakers, acid-base reactions and oxidizing-reducing agent combos. Master these concepts, and you're not just going to pass your exams, you're going to be a much safer and more effective pharmacist. You've got this. Keep up the great work, and I'll see you in the next explainer.